Hello everybody, I'm Taj, and today we're going to be going over a northern blot and a nucleosome protection assay. So starting with the northern, a northern blot is used to detect RNA. So first, the RNA is separated by size in gel electrophoresis. Then the RNA is transferred by blotting to a nylon membrane. The next step, the RNA is detected by a probe, which would be a complementary RNA sequence to the target RNA that is trying to be detected. So that complementary RNA sequence will bind to the target RNA, which is hybridization. And this is what allows that target RNA to be identified. So when we're looking here at our northerns, we can see in column 1, we have the marker RNA for the wing gene of a fly. And then in the second column, we have the fly abdomen RNA. So then right here, we see a bar indicating the presence of wing gene RNA. And then when we look in column number 3, this is the human abdomen RNA. So in human abdomen, we don't see a band indicating the RNA for the wing gene. So this would indicate that humans do not have the RNA for a wing gene. Now moving on to a nucleosome protection assay. This one is a little bit more complicated. So nucleosome protection assays, they detect the transcription of a gene by measuring the degradation of DNA by DNase. So the presence of histones normally protect DNA from degradation, but when the histones become acetylated or phosphorylated, when the DNA is ready to undergo transcription, the chromatin becomes less dense and leaves the DNA vulnerable to degradation. So when we look at our assay here, we see we have our marker DNAs and then our fly abdomen DNA. We can see in the marker DNA we have our wing gene here, and then in the fly abdomen DNA we have our wing gene here. So now when we look at the third column, we don't see anything here. So no DNA is present in this one because the wing gene is actively being transcribed in the fly abdomen DNA, which means the DNase has degraded all of that DNA. So when we're comparing a nucleosome protection assay to a northern, the lack of detection of DNA would be a positive indication of expression for that gene. While in the northern, when we do see a line, this is the positive indication of expression. But then when we don't see one, this means the gene is not being expressed. So back to the nucleosome protection assay. When we go back to looking at the human abdomen DNA now, we see that DNA is present in the assay because the wing gene is not being transcribed in the human abdomen DNA. So therefore, that DNA is protected from DNase by its histones. So there it is. That is a northern compared to a nucleosome protection assay. Thank you.